Hello, and welcome to our Evaluating the Problem Systems presentation. My name is Joe, and with me we have Pei, James, and Noor.
And our instructor problem that we're exploring is the lack of interaction in online classrooms. Although online classes have been a thing since the past decade, a majority of students have been forced to take online classes due to the pandemic. While in online classes, students are unable to actually interact with their classmates or teachers, creating a poor substitute of in-person classroom. Um, we've all been in scenarios this year where a teacher asks a question to a Zoom room full of the black screens, only for silence to take center stage. This is why we have decided to study this exact part of our problem system. Just how much do students actually interact with teacher in online classes, since we are all part of this issue every school day. So it is important to delve into this problem further.
We chose to collect data on a rate which students talked or interact with the class/teachers. These forms of communications range from chat boxes to unmuting microphones. Unfortunately, our team consists of members only in complete asynchronous classes, so we weren't able to compare the data to an in-person classroom. However, this data collection can be used and replicated later on for future testing when COVID-19 regulations have ceased. This part of the problem system is important to obtain and understand, as it would provide justification for an improvement in the online structure of classes.
All right, so for the data collection plan, we planned on monitoring the interactivity in online lectures. So we collected this data by taking notes of how often students talk, whether in voice or chat, with either each other or the professor. As student participation data can be further extrapolated through multiple ways, such as indicating whether a student's video is on, which here is a step-by-step instruction to replicate the study. So note, notes can be taken either on paper or on laptop on software like Word or Google Docs. So first in this little step, so for one, considering the accuracy of the data collection, we choose 2 small classes of about 30 people and 2 large classes with more than 80 people. So, and then 2, we joined a Zoom lecture on time and took note of the amount of participants and how many of them joined. If any students' cameras are on, we took note of that as well. And 3, when a teacher asked the class a question or weighted possible questions from students, we took note of how many students responded and whether or not they were a voice or a chat box message. We noted the student's name as well in order to tell whether or not the same student interacts multiple times. And so 4, if students talked during the lecture without a teacher's prompt, we took note of this interaction as well. We then took note of whether or not the class was a week away from corresponding tests to collect secondary data as well.
So here we have our visualizations of our data with our primary and our secondary data. But first, let's explain our primary data. Each quadruple pair here in this graph represents a percentage of that specific type of group. For example, these 4 bars here represent the total percentage of students who responded at all during a class. Our next 4 bars then take that same percentage and divide how many of those responses were in chat form. Now, if you look closely, you'll notice that the sum of the percentages of mic and chat responses are greater than 100%. This is because there were occurrences when the same student would respond more than once. Now, based on this primary set of data, overall, less than 50% of students responded in these 4 different classes. And most of these responses were in chat form. For example, around 77% of responses in RLCL were communicated through text, while only 51%, which again is people that may have talked more than once, only responded by mic. We noticed that smaller classes actually have more students with cameras on as well. We can also see that our bigger classes end up having less total responses in comparison to smaller classrooms. So now let's take a look at our secondary pieces of data. Using the same type of data that we have from our primary graph, we took note of classes that were actually within 7 days of an upcoming test that corresponds to that class. You see, during our pilot plan, we had noticed that there was actually an artificial increase in questions asked during test review lectures. Assumingly, this is because more students actually care about the course materials since there was a test right around the corner. So in our final plan, we took account of this and decided to use this as our secondary data. Now, as hypothesized, we can see that overall, there were more interactivity in these test review lectures since more students started to cram for test material. Now, technically, our data collected here could actually be the exact same type of data that we would have collected during in-person classes. But in reality, one can't help but notice that there are definitely differences in participation between in-person classes and online classes. Using our data, we can see that there seems to be a relationship between the size of a class and how many students respond. We noticed that if a class had 80 or more students, there was actually a significant drop in responses when compared to 30-size classes. This may be due to the fact that students don't feel as comfortable in a class with a ton of people than a class with a more intimate setting. However, as mentioned in the beginning, this data could prove fruitful for later areas of study during in-person class monitoring, as we could compare just how much of a difference in interaction there is between online and in-person classes.